Okay, so next we have our range rule of thumb. Right, we're all working on our new notes, correct?
The new ones?
The new notes, yep.
What about the last page to the old?
Oh, are we still working on the old notes?
Yeah.
Oh, no, we're still in the old notes. I'm sorry. Yes, we're still in the old notes.
There's like 2 more pages.
Yeah, range rule of thumb. So it's based upon the idea that for many data sets, most of the data, roughly 95% of the data, will lie within 2 standard deviations of the mean. By 2 standard deviations, we mean here's the mean. We go 2 standard deviations this way. We go 2 standard deviations that way. So within, remember, if you go to the fair. Who's ever been to the fair? And the guy says, "Oh, well, guess your age within 3 years, and you win this prize." Right? And the prize is really only worth $2. You're paying $2 from the guess, but that's okay. No worries. He guesses 30 years old. Within 3 years, what's he allowed? 27 to 33. You take 30, his guess. He gets his error, right? Within 3. So he gets 3 this way. He gets 3 that way. So 30 minus 3, 30 plus 3. Good. Here, when we say within 2, it means you take your mean and you subtract a standard deviation twice. You go 2 this way. You add a standard deviation twice. That way. Between these 2 numbers, 95% of the data will be between these 2 numbers, roughly. What's our guideline for unusual? 5% or less. So if 5% or less is our guideline for unusual, then usual will be the other 95%. Is that, you guys kind of following with me? So unusual is that outer 5%, the inside, the inner 95%, that's the usual stuff. So that's why we're saying that usual values will be within 2 standard deviations of the mean. So we just need to find our mean and subtract 2 standard deviations, and then add 2 standard deviations both. So let me show you what I'm talking about here. Did I not do that? No, of course I didn't do that. So we're going to take our mean, and I would really recommend that you do this part first, because what people want to do is they want to take the mean, and you all just like to do things in order. So you'll subtract, a lot of people will want to subtract 2 and then multiply by standard deviation. So they'll end up with, a height of a 6th grader being, of a kindergartner being 36 inches. I have no idea if that's accurate. Give or take 6 inches, and they'll end up with the minimum usual value being 240 to 337 or something like that. And it's like, does that make any sense at all? No. But they've taken the mean, and they've added 2, and then they multiply by the standard deviation. So it's not, it's something clearly is wrong. So in general, always, if you have an average, your average better be between the minimum and the maximum. Always. Right? If you have the average height of a 6th grader, and the shortest one is 30 inches, and the tallest one is 45 inches, you better not have an average of more than 45 inches. But your average better not be 60 inches. Do you guys does that make sense? So that's the first thing. And the second thing is, when you have your usual values, your mean should be smack dab in the middle of it. So if your mean is 40, your range better not be from 120 to 210. It better be centered around that mean. If not, that means that you did this weird thing where you subtracted 2 first and then multiplied. Instead of, remember order of operations, you multiply first and then you do the addition subtraction. So what I would recommend is you just find this part first and then you do that. Another way you could do it is this. So let's see. Let's give ourselves a mean of 40 and a standard deviation of 5. Does that seem reasonable? Just for purposes of explanation. So here's my mean. Within 2 standard deviations means I go 2 this way, plus 5, plus 5. I end up with, at 50. I go back 5, minus 5, minus 5. I end up at 30. So it means that the lowest usual value would be 30, the highest usual value would be 50. Does everyone understand what I'm saying? Here's my mean. I'm going to go 2 standard deviations this way, and 2 standard deviations that way. I'll make it S. I can make it S. It's probably a little bit cleaner. I could have just done this. Find 2 standard deviations. 2 standard deviations is equal to 2 times 5, or 10. So then I could have just taken 40 plus or minus 10. That means the min is 40 minus 10, 30, and the max is 40 plus 10, 50. Does that seem better? So why don't you guys try the sample below that using the chocolate chip cookies and the 40 chocolate chip cookie, right? So here you have. Don't you guys have this, or do you guys not have this? Do you guys have this?
You got it.
Are you sure with them? Yeah, find that. Do you guys want me to leave this up here or not? Yeah? Okay. All right. The usuals are always going to be 2 standard deviations. The usual ones. We're going to do some stuff in a minute that will be not 2 standard deviations. It'll be other, within the others, but the usual ones are always 2. Yeah. What's your mean in your problem? What's the mean?
24.
What's the standard deviation?
2.6.
2.6. So there's 2 ways of doing it. I'll do it first we'll do it doing the drawing way. 24. And then we're going to jump 2.6 this way, twice, right? So I'll end up with, if I add it twice, see how I'll get 26.6, 29.2, 2 this way, 21.4, minus 3, 18.8. Or you could do the other way and say 2 standard deviations is equal to 2 times 2.6, 5.2. And then do the minimum is equal to 24 minus 5.2, 18.8, and the max is 24 plus 5.2, 29.1. All right, so you guys have your minimum and your maximum, usual values. So the minimum typical value is 18.8. The maximum usual value is 29.2. Is 30 chocolate chips unusual?
Yes.
Yeah, it's more than the maximum typical value, usual value. So, yes.
So anything in that range is usual.
Yeah. It's not in the range of 18.8 to 29.2. Good?
Yes. Thank you.
All right. Questions? Do you guys need 30 seconds to check in with your neighbors? All right.
Coefficient.
Yeah, here it is prettier. All right. Now, yeah, Carl.
Okay, so I wasn't sure if I missed something. So with the 40 chocolate chip counts,
Mhm.
what is that 40 influence?
It implies that it's a sample of 40.
Okay, so that's a sample.
Yeah.
Okay.
Yeah. So it means that the 40 chocolate chip counts. It means you counted 40 chocolate chip cookies,
Okay.
and you broke them all apart and like figured out how many chocolate chips are in each one of them.
Okay.
Which is kind of a bad use of chocolate chip cookies, right? You can eat the crumbs, I suppose. All right. So let's take a look at this one. Comparing variation of different samples. Brandon. Oh, sorry, you're drinking. Gina, go ahead, read.
Okay. Comparing variation in different samples. It's a good practice to compare two sample standard deviations only when the sample means are approximately the same. When comparing variation in samples with very different means, it is better to use a coefficient of variation.
Right. So in other words, we're comparing samples with very different means. So if I have a bunch of pieces of paper here, I'm looking at their lengths, or their widths, I would say that they might have a variation of like 2 inches maybe. Standard deviation of 2 inches. These papers, their mean is going to be like somewhere right around here, right? If I look at buildings, like if I looked at a bunch of buildings, like 4 or 5 buildings, and the 4 or 5 buildings had a standard deviation of 2 inches, they'd be like practically the same. You know what I'm saying? I mean, if you build a whole building, and you can come within 2 inches difference in these 4 buildings, that's pretty amazing. They're like basically the same size. Does everybody kind of agree? You see what I'm saying? Versus, if I look at these 3 pieces of paper and how wide they are, if they vary by a couple inches, that's a little more significant, right? There's a lot less you can write on them if you give or take 2 inches. Versus a building, give or take 2 inches. I mean, if you guys just nudge that in 2 inches, you would barely even notice it, right? So so what they're saying is, what you should look at is not just the straight up size of two standard deviations, but you should consider how they relate to to the whole, right? And the mean is a good approximation of their whole, right? The average size of one. So instead, what you do is take every single standard deviation, figure out what fraction of the whole it is, right? Kind of figure out its relative frequency in a sense, what fraction of the whole it is, what percent of the whole it is, and then multiply it by 100% to express it as a percent. So for a sample, you do that. For a population, standard deviation over the mean, sigma over mu, same thing. So why don't you guys find the coefficient of variation for Chips Ahoy cookies in the last example. So your x bar was 24.0. What was your s again?
2.6.
2.6. Find it. Find the coefficient of variation. in 30 seconds.
Oh, no, that's square.
Oh, Patrick's here.
You got 6.5?
Pat's still not here. All right, your 30 seconds are up. Coefficient of variation. Andre, what'd you do? What's my S? 2.6. What's your X bar? 24.0. So 2.6 divided by 24.0 times 100%. Do it quickly, tell me you get. 10.8%. Good? Everybody on board? Super easy, right? That'll be some of the easiest 2 points you'll get on the exam. Next, we have Chevy Chevs. It's fun to say, Chevy Chevs.
Chevy Chevy.
Chevy Chevs. Rosa, have you read yet?
No.
Go ahead.
Portion or fraction of any set of data lying within a k standard deviations of the mean is always at least 1 minus 1 divided by k squared, where k is any positive number greater than 1. For k equals 2, at least 3/4 or 75% of all values lie within 2 standard deviations of the mean.
Okay, so what that means is, if I want to know within 2 standard deviations, k is 2, then I will put in 1 minus 1 over 2 squared. What's 2 squared? What's 2 squared, guys?
4.
4. 1/4. 1 minus 1/4, 3/4. So at least 3/4 of the data will lie within 2 standard deviations. Keep reading.
For k equals 3, at least 8 out of 9 or 89% of all values lie within 3 standard deviations of the mean.
Right. So I want 3 standard deviations. 3 goes here. What's 3 squared? 9. 1 minus 1/9. 8/9. At least 8/9 of data will lie within 3 standard deviations. So if I go 2 standard deviations in either direction, 2 this way, 2 this way, then at least 75%. Usually more. We just found in the last example it's more like 95% typically, right? At least 75%. At least means that much or more. You must be at least this tall to ride this ride. Can you be taller than that? Yes. So 75% or more. Everybody on board? Chevy Chef says the bare minimum is 75%. The great powerful thing about Chevy Chefs is this. It applies to all data sets. You can make up a bunch of numbers and bring me, you cannot find a group of numbers that you can bring to me and it won't follow this rule. No matter what, you can try to find any set of numbers you want, and if you bring them in and say, here's some numbers, if you find the mean and standard deviation of those numbers, then at least 75% of the data is going to lie within 2 standard deviations of the mean. If you find the mean and standard deviation of that data set, at least 89%, well 88.9% will fall within 3 standard deviations of that mean, no matter what data you bring. It's super cool. It might be more, it could be 100%, right? But at least 75% for here, at least 88.9% for there. What does that look like? Looks like this. Here's my mean. I'm gonna, whoops, I'll do that in this color, it's better. Here's my mean. I'm gonna go over 2 standard deviations. I'm gonna go back 2 standard deviations, and at least 75% of my data is gonna lie between these 2 values. If I go over 3 standard deviations, front and back, within 3 standard deviations, then at least 88.989% is going to lie between those 2 values there. At least. Usually more, but bare minimum at least that much. So Chebyshev sets the minimum. Could be 100%, but at least 75%. And here could be 100%, but at least 88.89%. So you guys, here's your example. I will start you out with the start at least 75%. Blah, blah, blah. What did I write? You said it's data? Oh, data. Yeah. Will fall between blank and blank. And then you guys should mimic the next one. We'll say at least 88.9% of data will fall between blank and blank. So fill those spaces out. The first one should be 75%. Second one should be the other one we talked about, which I just wrote down a minute ago to erase. So for Chebyshev's, I'm just going to focus on 2 standard deviations and 3 standard deviations, because I think that's enough. Figure it out.
So let's just say there. This is for the usual. 70 to the 130. Add by 30.
Does this help you guys at least a little bit fill in those blanks up top? You need to know this information.
Yes. Oh, I get it. It's the same thing, but plus 3
Okay, so the second one is at least what percent will fall between, what's this number here? 89 or 88 point,
89%.
yeah, 89% or 88.9%, anything, yeah, that's fine. Of data, so 75% data will fall between what and what?
70 and 130.
70 and 130. 2 standard deviations, right? Two standard deviations. And 88 0.9% will fall within what standard deviations? 55 and 145, which is 3 standard deviations. All right, everybody good with this part?
Yes. Yes, ma'am.
Makes sense? Do you guys need to talk to your neighbors for 15 seconds? Okay, talk to your neighbors.
You look over too.
700 is your base. That 30 is the mean is the
Okay, let's bring it back in. Here is the, here it is prettier. Okay, so now we're going to talk about normal distributions. Remember last week we talked about those, how it starts off low, like it makes a bell curve, comes up to the middle, and drops back down, like a bell curve, like a bell. It's symmetric, roughly. This is where the mean, median, and mode all are. Half the data falls here, half the data falls there. That's a normal distribution. Most of what we're going to be doing in this class is going to involve normal distributions. If it's a normal distribution, or approximately normal, we can do better than Chevyshev's. Chevyshev's says at least 75% falls within 2 standard deviations. So Chebyshev says between 75% and 100%. That's what within 2 standard deviations, it's going to be between 75% and 100%. If it's normal, the empirical rule says about 95%. So here's 75% to 100%. About 95% means it's right around here. This is its range. Do you guys see what I'm saying? Versus this range. Chebyshev also says, Chebyshev says that between 89% and 100% will fall within 3 standard deviations. Empirical rule says if it's normal, it's right around 99.7%. So instead of this range, you've got this tiny range here. So the empirical rule, if it's normal, it gives you a lot finer range. Instead of this big range, it says it's kind of more like right around here. And it also tells you within 1 standard deviation about 68%, which Chebyshev doesn't even really cover that, can't address that. So this empirical rule is also known as the 68, 95, 99.7 rule, not surprisingly, because it says that approximately 68 will fall within 1 standard deviation. So if I go 1 standard deviation this way and 1 standard deviation that way, approximately 68% will fall between those 2 numbers. If I go 2 standard deviations this way and 2 standard deviations that way from the mean, then approximately 95% of the data will fall between these 2 values. And if I go 3 standard deviations this way and 3 standard deviations that way, then approximately 99.7% of the population will fall between those 2 values. Everybody on board with this part? Okay. So, you guys figure out this here.